Alright, in this video we are going to be talking about section 2.3 and we talked about how to use your calculator, and of course the calculator makes it a lot easier to problem solve. So the next we talked about the rules of significance, and now we're going to talk about the rules of rounding. Alright, so suppose your calculator displays a number such as 8.4234, all right, and you want to round it to 3 sig figs. So the rule is the retained digit, which would be 2. If the digit that is going to be dropped is 5 or greater, then you're going to add 1 to the retained digit. If it is less than 5, then you will have the retained digit as is, all right? So the 3 and the 4 are getting dropped. So 3 sig figs, rounding to 3 sig figs will give you 8.42, okay? If you want to round it to 2 sig figs, on the other hand, again, the same rules of rounding apply. And now you would drop the 2, 3, and 4, and you would record your answer as 8.4. Here again the same rule. If you want to round it to 3 sig figs, because 8 is greater than 5, you're going to add 1 to the retained digit, so you'll record your answer or number as 14.8. Suppose you're going to have just 2 sig figs in your answer, then you're going to add 1 to the 4, because that will be a retained digit, so it becomes 15. All right. Now here in 3256, 3 sig figs, you'll add 1 to the 5, but the magnitude cannot change. All right. Okay. So you can't record this number, and I've seen this sometimes where they record the number as 326. Now there's a big difference between 326 and 3260. All right. So you are dropping the 6, okay? However, you are putting a 0 in its place in order to maintain the magnitude of the number, which is in the 3000s. If you are going to round it to 2 sig figs, then you're going to add 1 here, and it will become 3300. Or you can write this in scientific, move the decimal point 3 spots, 1, 2, and then 3 to the left. And so you can record this as 3.3 times 10 power 3. All right. If that is more helpful, you can do it that way. All right. Write the correct value when 3.1457 is rounded to 3 sig figs. So if you're rounding it to 3 sig figs, you will retain the 4 but add 1 to it, because this number that you're dropping is 5, all right? So 3.15. If you're rounding it to 2 sig figs, then it'll just be 3.1. All right. The rules for significance in multiplication and division. You're looking at what you're doing, all right? So in your multiplier, you're having two numbers here. This has 4 sig figs and this has 2 sig figs, all right? Since this has the least number of sig figs, so will your answer. So your answer should have 2 sig figs. So even though your calculator display might come out like this, you're going to round it to 2 sig figs, which will be 8.6. Again, the same rules apply for multiplication and as well as division, all right? So you look at the numerator and the denominator, all right? So 3 here, but 2 here, okay? So your final answer should be 2 sig figs. And then when your display comes out like so, you still want to round it to 2 sig figs, which would be 3.4. Now, if your answer doesn't have the proper sig figs, You can definitely add more zeros after the decimal point to give you as many sig figs as you want. All right. So for example, 6 divided by 2 gives you 3, and that comes out as 1 sig figs. However, in your answer, you should have 2 sig figs. All right. So you can put a decimal point and then a 0 to give you that 2 sig figs. So when you perform this calculation, again, you can see that your final answer should have 2 sig figs, right? 3 here and 4 here, but the least is 2 sig figs. Therefore, your final answer should have 2 sig figs. So 8.5 is the final answer because your calculator display is 8.52. So you drop this and retain the 5 as is. When you're adding and subtracting, the rules of significance change kind of slightly. You're still going by the least sig figs, but it will be the least sig figs before or after the decimal point in whatever numbers you're adding or subtracting. All right, so this has numbers to the thousandths place. All right, so it has tens, hundreds, and the thousandths place. This is to the hundredths place, but this is only to the tenths place. So your final answer should also have a number to the tenths place. All right, okay. So you add them up as is. This is your display, but your answer should be rounded to the tenths place. All right, because that's the least of what you have in the number 3.0. All right, okay. So you will record your final answer as 66.1. Similarly, when you're subtracting, in the first number you have to the hundredths place, but in the second it's only to the tenths place. So even though your display comes out as 62.09, you will round it to the tenths place. All right, you're adding this following measured numbers. You can almost ignore the 0 and the 9. So this is going to be 104.4, and you will record this to the final answer to the tenths place. All right, the number of sig figs in this number, 2.0045 liters. So these zeros are between non-zero digits, so they are significant. So you have 1, 2, 3, 4, and 5. 5 sig figs. Answer the following equation using the proper number of sig figs. So you are adding all these numbers, and 15 doesn't have any number after the any digit after the decimal point. 10.2 has one digit in the tenths place, 0.2 has one digit in the tenth place. However, 15 has only the least digits is in the ones place. Therefore, your final number should have digits before the decimal point in the ones place. All right. So 15 plus 10 is 25, and that will be your answer. So answer the following equation using the proper number of sig figs. All right, I'll have to use the calculator here for this. Okay, so coming back here, you had 5 sig figs, and then the answer here is 25. And then here, when you do the math for this, 4.7 times 834.78. Okay, so now you have to round it to 2 sig figs using the rules of significance for multiplication. So you will bring this decimal point 1, 2, 3, all right? So 3.9 times 10 power 3, okay? Okay, so that's the answer. All right. Now here, 15 times 4 is 60, okay? And then 2 sig figs, so you can make it into 0 with a dot, and then minus 30, and there's the decimal point here to make this 30 into 2 sig figs. So again, your answer is going to be 30. Okay. All right. So coming back again. Whoops. Sorry. All right. Prefixes and equalities. Okay. All right. So you need prefixes to convert from maybe a smaller unit to a larger unit, or to the base, and vice versa. All right. So it makes it easy to do these conversions because everything is in units of 10, as I explained. All right. So between the kilo and the mega, there's a difference, numeric value difference of 1,000. All right. So 1,000 kilograms or 1,000 kilometers is the megameter or megagram. Okay. Okay. Giga is so the mega is 1 million more times more than the base. 1 billion times more is the giga, and so on. Okay. These are not used as much. However, if you go to the next slide, these are used quite a bit, right? Especially the deci, centi, not so much the deci, but the centi, milli, micro, nano, and so on. Okay. So you need to know the equivalents. All right. So 1/10 of the base is deci. 1/100th is centi, 1/1,000,000th is milli, and so on. All right. So a million, a million of the millimeters or milliseconds or milligrams is a gram, the base unit. All right. Okay, we'll go to this table in the next slide to make this a little bit more clearer. So you can see the base unit for length is the meter, right? Okay. So 1/10 of that base is the decimeter. All right. 1/100th of the base is the centimeter. That means there's 100 centimeters in a meter. There's 1,000 millimeters in a meter. There's, I think I said that incorrectly in the previous slide, there's a million micrometers, not milli. There's a million micrometers in the meter. All right. Okay. So between the meter and the micro, there's a difference of a million. Okay. There's a billion nanometers to a meter. Okay. 10 meters, 10 times the base unit is the deca, 100 times the base is the hecto, and then 1,000 meters is the kilometer. Okay, and then you can see something very similar for the liter. All right, liter is the base. Okay, again, 100 centiliters in a liter, 1,000 milliliters in a liter, 10 deciliters in a liter. All right, 10 liters is a decaliter. Again, one of these deca and hecto are not as encountered as commonly, but liter and kiloliter are. All right, so there's 1,000 liters in a kiloliter, a million liters in a megaliter. All right, and so on. So you can do something very similar for second. You can also do something very similar for mass as well, using grams. All right, you can write down a similar table. All right. Okay, I'll have to stop here.